Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. One of the main advantages of the WaveSource line of light sources is that two wavelengths are integrated into a single port. By having two wavelengths in one port, only one reference cable is required, which then allows for automatic dual wavelength switching capability. This auto switching feature saves time and eliminates wavelength mismatching errors, since the light source and power meter are synchronized when both units have auto mode enabled. This video will demonstrate how to enable auto mode in the WaveSource light source, and will show the user what typically happens when an OWL power meter and WaveSource are both set to auto mode. Before we begin, it would be helpful to cover the keypad of the WaveSource. Near the top of the keypad are the indicator LEDs, which correspond to the optical ports on top of the unit. The left-hand port is labeled MM port, which stands for multi-mode, and the right-hand port is labeled SM port for single mode. Below the indicator LEDs are colored circles which show the wavelength that corresponds to current color of the indicator LED. For multi-mode, red is 850 nanometers and green is 1300 nanometers. Likewise, for single mode, 1310 nanometers is red and green is 1550 nanometers. The power button powers the light source on and off. The port button switches the WaveSource output between the MM and SM ports. So right now the multi-mode port is active, so if we press the port button, it switches over to the single mode port. And then we can also go back to the multi-mode port by pressing the port button again. The CW mod button toggles the light source output between continuous wave, or CW, and modulated, or mod. In CW mode, the indicator LED is solid, as you can see here. In mod mode, the indicator LED will flash. When using the light source for optical loss measurement, always have the output set to CW. The lambda/auto button has two functions. Pressing this button once will switch to the other wavelength in the port currently in use. So right now the indicator LED is red, so it's outputting 850 nanometers. If we press the wavelength button, it switches to green. Now it's outputting 1300 nanometers. Again, pressing lambda will switch it back to 850. The other function of this button is setting the wave source in auto mode, which will be explained shortly. For the purpose of this demonstration, we will use the multi-mode port of the WaveSource quad, which occupies the left-hand port. The optical power meter used in this demonstration is the FiberOwl 4. However, the MicroOwl 2 and Wave Tester optical power meters also have auto testing features. First, enable auto mode on the power meter. On the FiberOwl, this is simply done by pressing the auto button. On the MicroOwl 2, you simply press the 1 button. And on the Wave Tester, you press and hold the lambda/auto button. Now, notice that the power meter wavelength toggles between auto and wavelength. This means that the power meter is monitoring incoming light for an auto test signal from a wave source, but is not yet receiving one. If the power meter shows under or low, this is normal because the light source has not yet been powered on. In this case, I already have the power meter and light source powered on. Moving to the wave source, when powered on initially, the wave source is set to 850 nanometers, which means the LED will be red, as it is shown here. When switching the wavelengths to 1300 nanometers by pressing the lambda button, you'll notice that the LED flashes briefly, then becomes solid green, which means the source is now set to 1300 nanometers. The brief flashing period you saw is the signal to the power meter to switch to the other wavelength. Pressing the wavelength button a few times and watching the power meter display, you will see that the wavelength switches accordingly. The wave source can also be set to switch between wavelengths automatically by enabling auto mode. This is done by briefly holding the lambda/auto button, then when the LED begins flashing, immediately release the button. You will then see the indicator LED alternate between colors and between solid and flashing. I will demonstrate this now. Notice the indicator LED is alternating between flashing and solid and also between red and green. Okay, looking back at the FiberOwl power meter display, notice that both wavelengths appear on the screen. This would also be true for MicroOwl 2 series power meters. On the Wave Tester optical power meter, only one wavelength would appear at a time, but would alternate between 850 and 1300 in this case. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.